Okay, I'm back, and so now let's redraw the water molecule because we're going to use it here in just a moment. So we said that the water molecule consists of an oxygen, and then it's got two hydrogens, and then we remembered that there was an electron that came from the oxygen, and then there was an electron that came from the hydrogen, and similarly over here. And we said that the oxygen and the hydrogen were sharing those electrons. Well, it turns out that the oxygen is a bully. So because the oxygen is bigger, it has more protons in its nucleus than what the hydrogen does. That means it's got more electrical pull. And so that means that the two electrons are going to spend more time around the oxygen than they do around the hydrogen. So that means that the oxygen, one side of the oxygen is going to be negative, and then this other side that's more closer to the two hydrogens is going to end up being positive. So the electrons are negative. They're spending more time around the oxygen. So this side of the oxygen is negative, and then this side's positive. Now when you add negative and positive together, it's still going to be zero. So overall, the charge on this molecule is zero. But it has part of it has a partial negative charge, and part of it has a positive charge. So we say that this is called a polar molecule. It has two poles, just like a magnet. Well, who cares? So now what we want to do is to take these molecules, and we want to put them together to make more complicated things. So let's take water, individual water molecules, and glue them together. So that's going to be the picture that is on the right hand side, and it's the upper one. And so this is going to be called a dipole-dipole interaction. Dipole interacting with another dipole. So do you notice that the negative end of this dipole could be attracted to the positive end of another water molecule? So up here, so there's your another water molecule's up here, and do you see how they lined up so that this negative end is attracted to that positive end? So water sticks to itself, and that's how we make liquid water. So liquid water is going to be when you have clumps of individual water molecules that are sticking together because they have opposite charges. Now, when you freeze it, so if you continue to lower the temperature on water, eventually it turns into a solid. And when it turns into a solid, you can kind of see it in that picture right there. But what happens is that it starts to make hexagons like this, where you got a water molecule, water, 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 and then you got this space in between. Well, what that does is whenever you've got frozen water, it makes these compartments, and that means that the water molecule kind of spreads out, and that's the reason why water floats, is because it makes these little hexagon things. If in elementary school, you should have made snowflakes. So you make snowflakes with a piece of paper, and then you fold it into a triangle, and then you cut it, and then you open it up, and now you got a snowflake. Well, did you notice how many sides does a snowflake have? It's got 6, because it's frozen water, and it's got this kind of internal structure to it. Another interesting thing about water is that it can pull molecules apart. So take a look at the bottom right-hand picture, And so this is going to be an ion dipole interaction. So we talked about salt. Salt was NaCl. Was it got Na sodiums and it's got chlorines. Now the sodiums are going to be positive and the chlorines are going to be negative. So can you see that the negative chlorines would be attracted to the positive end of that water molecule, whereas the positive sodiums, the Na pluses, would be attracted to this end of the molecule. And so what can happen is when you take salt and you put it into water, the water can pull apart the salt and it can dissolve it. So that, again, this is a interaction between a molecule and another kind of molecule. Now over on the left-hand side, those are some other ways that molecules can glue to each other that we're not going to be interested in so much in geology. The top one shows how oxygen can turn into a liquid. So oxygen, the kind of oxygen that you breathe, is O2. So it's got two oxygens. And you might wonder, as you lower the temperature on oxygen, it actually turns into a liquid, just like liquid water. And that's because these oxygens are kind of vibrating back and forth, and so one end of the two oxygens can become positive for just a split second, and the other end can be, one side can be positive, the other can be negative, but then a split second later it reverses itself. And so if you've got for a split second a positive one over here and a negative end over here, those two oxygens can glue together. And so that's how you can make liquid oxygen. The one that's underneath it show this one, that one's going to be called hydrogen bonding. And so what happens here is that sometimes the hydrogen in one molecule can be attracted to another atom in another molecule, and they, again, they're stuck together. So that's a picture of your DNA. And so the forces that are holding the rungs of the DNA together is going to be called hydrogen bonding. We're not that interested in that. All right, let's take a break, and when we come back, let's see an application of this kind of bonding.